thing underneath that orange stop peg is the needle. I gotta readjust this one for 0. Pretty cool, huh? I got a program in-house that allows me to print these, any meter face any way I wanted it. I could put a logo in there and do it in colors. The program's called Meter. M-E-T-E-R, Meter. The free version of this program is called Meter Basic. You want to run it on a Windows-based platform. The actual program itself is like 15 or 20 bucks. And because some gentleman was kind enough actually to write the program for us, I went ahead and I bought the full version. I think the trial version of the program doesn't allow you to do color, and then you can't export the file. But it gives you a general idea what you're doing. This is really neat. These are Simpson meters that I converted over and put custom back plates in that I did in-house here. It's really simple to do. Next step is, as far as the meter evolution is concerned, I got a meeting with my vinyl guy tomorrow night where we're going to sit down and figure out how we can go about doing this in vinyl. So I can do a vinyl print, or I can export it to a silk screener and have that done. And then we want to add phosphorescence to it, so it'll glow even with the lights off. Soft backlit meters. It's done with warm LEDs, and instead of having them faced up, I have them faced off the front of the Simpson meters, shooting this way, and then it's reflected light to help dampen it. Pretty cool, I think. It took 4.5, almost 5 hours to do, but it's done. So this is now ready to go onto those over there. Gentlemen, this is going to be a fun week, and I'm going to shoot a lot of video. So I hope you guys are sitting down, got your pantyhose on, and make sure we got our wigs twisted on straight, because this is going to be a long video. It's Sunday morning, Saturday night. Let's get this party started. Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Good morning, kids. So, I'm just sitting here trying to get my bearings, right? So now there's a lot of little tips and tricks that I'm going to give you on putting the amp deck together. Now, there's going to be people out there that are going to have varying, listen to me very carefully when I say this, varying definitions of what I do here and what I don't do here. This whole process, this is where the real rubber meets the road, and where you've got all your components placed inside a cabinet make a huge difference in how the amp operates. Now, like I said from the very beginning, I got to set these guys up to either be able to run a 3, which this is my buddy Lee's dead 3000 he owned. It's an iMac. The anode across the top this way is about 4 inches. It's 4.09 inches exactly. Now, there's some pros and there's some cons, okay? Let's talk about the pros, and then we're going to talk about a performance con. Now, most of the time, you'll find that guys like to snuggle these up into the corner. They give it about 1.5 inches, maybe 2 inches of standoff from the wall, both sides. The tube lives to have something near it. Hold on a second, I got a jet flying over here. I got the shop door hanging open this morning. It's 71 degrees and it's 49 degrees outside. I'd be silly to turn on the air conditioning in here because, well, let's face it, I'm a fat kid and I like air. I like to be cool. I don't like to have booby sweat. Okay, so like I was saying, you'll notice that if you put the tube, let's say we move and mount the tube out here in the middle of the deck, all don't know why you would, but let's say we do. Okay. The downside to moving this out here in the deck is that the tube's going to be very sluggish. Okay. Now, this is called your cavity space, this internal portion of the deck. You'll find that if you snug this up against a wall, like this, you'll see a performance increase from the tube. The tube likes to have a certain proximity to the outside of the deck, and it's just, this is from me in personal operation observation. Okay, I've seen these and worked on these where the tube is mounted here and the tube is mounted out here. Most of the guys will tell you, put the thing about 2 inches from the wall, preferably 2 inches from both the walls, and you're going to see a huge performance tick up in the tube. The downside to that is that when we put the lid on it, our vent's going to be right in the middle of the deck, like right basically in line with my 2 fingers here and here. Okay, middle, somewhere about in here. Now, we don't want the air to come up and then immediately have to make a 90-degree angle. We want it to mostly come straight out. Okay. Now, most people, when they build these things, they don't bother putting them in a nice rack where everything's going to be safe. And there's some pros and there's some cons to building them in the server rack like this, or a nice big enclosure like an actual transmitter. You have to worry about other outside ventilation sources and that kind of thing. Now, the other thing that we have to think about as we're laying this out is that we want to have, there's a lot of energy here, a lot. You've got 2 different forms of energy, our RF AC and then our DC high voltage. Okay, it's no joke. They're both present on this top, and this is where they meet and where they separate. It's right here basically. So you're going to have your insulation distance of your high voltage, which is going to be roughly about 1 inch at this voltage, about 1.5 inches, 2 inches depending on how much humidity is in the air and what you're using as your insulator. In this application, because nothing, it's just free air space, we have to make our calculation. So on the top end of things, let's say we go crazy with it and decide we're going to put 7,000 or 8,000 volts on the anode, we need to be about 1.5 inches to 2 inches away. But about 2 inches is the butter zone for this tube. Well, right now, just eyeballing it, we're about 2.5 inches from the wall. Like I said, this anode is 4 inches across. From here to here is about 4 inches. A 6,000 is 6 inches across. Okay, hold on. I didn't want to start coughing on camera on you guys. So we're about 2 inches away from the wall here. About 2.5 inches away from the wall here. So now we got a 4-inch anode. Skip's starting to come up, it is. And now we're going to go to a 6-inch anode. So, planning for the future, wanting to give ourselves that nice 2-inch insulation distance, we need to slide the tube over and over to approximately about there. So, we got to think that the tube is going to be roughly 1 inch thicker all the way around in circumference. Okay, 4 inches, 6 minus 4 is 2. So it's going to give us 1 inch here and 1 inch here. So in theory, we have to think that we're going to be about roughly, anode's going to come out to about here, come out to about here, in all aspects, which will put us about 2 inches away from the wall here, and 2 inches away from the wall here. Now, I can tell you from personal experience, this is not going to degrade the operation of the tube too awful bad. If we end up having a problem, I'll just put another sub wall in here that comes up by the tube, stand it off the internal wall about 1 inch or so. So we got to figure that roughly we're going to set it at 3 here. Set it about 3 there. Okay, so I need to get me some stick. I'll get me some filler rod. Now, we're setting this filler rod up here just for a visual representation for you guys. Roughly, because you can't see it, the way the deck is orientated right now, the dead center of this thing, as far as the lid that goes on top of this rack, is going to be right here. But right now it's got a 3-inch fan. And what we're going to put on there is a 6-inch fan. So we'll measure out from the middle of our fan here. Come out 3 inches. Do this the other direction. We're just spitballing it. Trust me, there's going to be a whole lot more measurement off camera. The middle of the tube is going to be right on the edge of that fan. It's going to sit right here. And that'll work perfect. Now, if I wanted to, which I can do because I got to punch the hole in the top of the lid, there's already a perforated hole there, but it's only for a 3-inch fan. So I'm going to have to do multiple punches with the 120 millimeter punch, and I got to create this little bloom pattern. I can offset that just a little bit to this side, and it'll be perfect. It allows us to pull a vacuum in. Now this thing's got vents all the way down at the bottom to allow fresh air to curl up from underneath on the bottom, wick up from the bottom, and then on the edges of the doors it's going to be able to pull air in as well. This is a plus. That means all the air inside the box is going to get circulated, but by this top fan. If we offset the fan over here, we'll have a direct shot straight out the roof of this cabinet. And that overpressure, if there is any from the blower, which I doubt because we're going to lose velocity, this is going to act just like the other boxes I got, and this will work perfect. That's where I'm going to place the tube. These are the thoughts I have to have in my head as I'm going through this. I got a whole lot of stuff. There's going to be a lot of me talking on this video and explaining things to you as we go. Like, one of the major things that I'm going to cover is the relays. And my reasoning behind using the relays I'm using. Very valid form of thought. Believe me when I tell you. So, hold on to your underwear and buckle your shoe, guys. Here we go. I went ahead, and it's very lightly traced with pencil here. I went ahead and I slid it out another 1/4 of an inch, this direction and this direction in the deck, just for a little bit of a margin of safety. Now don't forget, we're also going to have that big thick-walled piece of Teflon that goes over the top of the tube, and it'll be the same way with the 6000 as well. This next trick I'm going to show you, you got to swear to me that you're going to take it to your grave, because this was taught to me by the great wise grandmaster tube builder. First person that mentioned it to me was the master Yellow Jacket when I was in California. We were sitting down and having a conversation about building 3s and 6s and stuff, and he says, man, the biggest trick that I learned is this. And then Prime mentioned it to me, and then my last teacher that I had was Shockwave out of Connecticut. Very wise man. Donald. Absolutely nothing but love and respect for that guy. A little bit weird, but then again, I think we all are. So, gotta love Donald. Got that marked. Let me show you this next. I don't know how well this is going to come out or not with the light, but you guys might want to think about buying yourself a set of these stencils. They're available at any hobby shop, any craft store. Stupid cheap. I've got 3 of these, and they go all the way up to, I think, 4-inch. And we happen to know that the base of the 3000 here is roughly 1.5 inches across, which is this punch here. Hold on a second. It's Monday. My phone's going to ring probably 75 times today. Mondays are the worst. Anyhow, you don't need this stencil to find the middle of the hole as your guide. Okay? You could simply take a tape measure and measure in, and then determine, measure up, and then you could dink, put a dot. Or, ghetto hood tactic, as my other teacher Prime likes to say, they mark on the stencil for us. So that just gives us a rough location. Now, remember, I'm doing this twice in a row, okay? So we now know that our rough placement, we want to have right there in the middle of them crosshairs, okay? So this is where we get out our ruler or our tape measure. And for duplication purposes, we're going to note from the edge of the cabinet, we're going to come in 5 and 1/4. Yeah, okay. 1/8. 1/8 of an inch. Then from over here, we're going to be roughly the same again. So now I'm off just a hair. Now I'm 5 1/4. Inch. This isn't the trick, by the way. The trick comes into play with the top lid. So, for me to go and transfer this and make sure the tubes are exactly in the same place in both boxes, we got to determine where that mystery point on the plate is going to be, right? Pretty simple. Now I could readjust and make them perfectly even, which I should probably do because there's going to be somebody out there that's going to lose their frickin' gourd if I don't. So we'll say 5. And an 1/8. So 5 1/8. This is our new point. Like I said in the previous video, any of us come into the world knowing anything. Got to be taught, right? So, I listen. I try to listen. Sometimes I don't listen enough. Sometimes I found myself doing this on the phone quite often, that people call me and they're going to ask me a question and I already know the answer. I'm just busy waiting for them to let me answer their question before they can finish asking it. That's my flaw. I'm working to do away with it. But in some circumstances, when I get around incredibly brilliant people that have done this a million times before me, especially when we're eating or something, I will sit there and I shut my mouth. And I just listen and I take mental notes. And this is one of the tricks that I learned from these guys. Take your base plate, drill a hole in it. Take your lid for your cabinet. Line it up with your lid before you do anything else. Line it up nice and even. Perfectly tight. And this is always step number 1 that I always do. We know there's going to be a little bit of an overhang. So you line that up tight. We transfer. And then you commit and you drill it. Why is this so important, you say? All the old timers out there that are watching this that know what the frig I'm doing, they're gonna like, yep, that's the best way to do it, boy. This now is my lid. So by determining I want to put the tube socket here and the tube here, how do I directly transfer that and get it perfectly in line with the center mass of the tube? Transfer it directly to the lid. And then from here I can measure out and find what my hole's going to be for my chimney, which is going to be about 4 inches around. Well, this particular ruler that I absconded from somebody at some point, it's got a little button in it. button that you can hold in place with a punch if you need to. So measure out 1, 2, 3, 4 inch. Now remember, we'd be measuring out 3 inches, correct? For a 6. But since we're running a 3, we come out 2 inches. And we can transfer our circle. If I sharpen my pencil up enough, this will swivel around this button point, and it'll give us a measured circle. That's one way to do it. Now me, knowing that we have a 4-inch orifice, I happen to have a 4-inch punch. So all I got to do is very carefully drill this hole out for the guide for the hydraulic punch. And it's going to be perfectly lined up. The tube, my chimney, will perfectly line up because I took the time in the very beginning to do good placement on my parts. On to the next step. Screw that brand new towel, it deserves to have holes in it anyhow. Walking around here all pristine and pretty and everything. Who's it think it is? I mean, who's it think it really is? Okay. Next step. So I have looked at every which way that I would feel comfortable mounting this. One option is to shave off this lip on the other side. It would actually be this lip here. Shave this off, bolt this directly to the back of the cabinet. Now these two plates are identical. The front and the back plates are absolutely identical. So I just literally came out here and Bob's your uncle, you're now back. This plate's now back. The problem is I run into some real estate restrictions on the inside. Now, if I'm really careful about how I do it, I can put my PL259 for my output right down here in the corner, and then have my input right down here in the corner, which will work out well internally because I want to put the relays so that they're on top of each other, so the RF that passes through the box has to travel as little distance as possible, as far as like signal and that kind of thing. Like, you don't want to have your input over here and your output over here. You want to have an AC box especially this style, you want to have your input and your outputs really close to each other, so the RF comes directly and goes to your relay and then can pass around. Now, you can put it over here in this corner, your input, okay? Or you could put your output over here, and you just have to change how the tube and everything's orientated on the inside. You can run that with coax over here to the relay. I'm not too hot on doing that. I would rather have a solid connection to the outside world. I'm still debating on how I want to do the relay on the inside. I'm still working that out in my head, but I do know what I need to do today is be able to get to the point where my air box is mounted. Now, there's an upside. My cord runs down this side of the blower. So if I go and I fabric cobble together a bracket and build an air box off of this bracket for the air to be able to go and bend in, into the cabinet, two things. Air is going to run right in and it's going to hit the side of the tube, one side of the anode. But remember, it's covered mostly with that chimney. But it's going to come in at an angle. So it's going to go in and pinball around the box on the inside. And that's what we want. We want the air to spin. We want to have tumbling of air on the inside of the box. Remember what I explained in the last segment is the more tumbling action we can get with the air, the more velocity we're going to be able to get to go up through the tube. That's the goal, is we want to maximize our volume, our CFM volume from our fan, and maximize our opportunity to get air up through the anode. Now we've also got the bottom side of the tube that we have to supply some air to. And how we're going to go about doing that is we're just going to drill a couple little vent holes down the side, and then a couple holes in perfect placement where we want them for cool air to blow out and run down onto our filament leads, which are going to carry most of the heat. Remember, the upside to these RF junk sockets is the more metal mass that we can add to the bottom of it, the better off we are. Oh, by the way, I found my this is your standard Henry socket. So instead of having the finger stock here, this replaces the finger stock. And these two parts look surprisingly the same. The only difference is this one's attached to a big giant plate and a heatsink. See, standoff insulators and the heatsink fins to help get rid of the heat off the bottom side of the tube. But these things are getting harder in frog's hair to find. Not saying that you can't find them, because they are out there. The price that people want for these sockets is just retarded. The last 3000 I built for a nice guy, I used an actual Henry socket with finger stock in it and everything. There's no downside to these. It's a good socket. The other sockets I had, not so hot for trot on. They do work. Don't get me wrong, they were in a transmitter and it was working for 30 years, so they do their job. I just kind of looked at them and went, no. A little bit easier to mount. Both systems are a little bit easier to mount than this. This is super cheap and this is way a good design. But like I said, I really wish we could get him to develop us a call-it piece, which I know if I keep pounding him, he will. He will. But today's goal for me is to settle on a bracket system that we can bolt down and have access to all four holes, and then be able to create some kind of louvered air box that allows us to blow air in. Remember, I'm restrained. I can't mount the fan this way. I wish I could. And I tried every which configuration I could think of. I was going to blow the air in from the bottom and create a bunch of holes in the floor and let the air exhaust through the cabinet and deal with all the restrictions of that. And I was just going to like waffle cheese the bottom around the tube socket. And then I thought, man, I could mount the tube on some mesh, or I could, no. This thing hangs down or is going to get in the way or be in too close a proximity to high voltage leads, or it's too close to the back of the cabinet, or this, laying this down, not only is it going to be cool and trick, I honestly feel this is going to be my best route. So I'm going to get this done today, and then I want to get all the other holes that I need to have in the back of this thing punched out. I want my filament to go here, my RF in, RF out over here in frame, and then I want to have my foot pedal hookup and my 110 lead for the blower, which will all this stuff, all this is going to be inside the deck. The capacitor, all this stuff will be inside the deck. I want to get all that mounted up. I want to get the floor of the amp punched out for the tube, and I want to start thinking about what I got to do to mount up my tuning capacitors. And today I'd also like to try, I don't know if I'll get that far or not, I'd like to try and get my tank coil built for both of these. So we'll see where we go. Okay, 2 trips to Ace, 1 trip to Home Depot, and 1 trip to Hobbytown. I think I got all the little bits I need. Oh, God, I'm getting to be a space cadet. Okay, so I've got the general idea of what I want to build. I want to build a frame that comes out to about here, goes across, I bolt it down, then I got to build a ramp and 2 side panels. So I'm going to build this out of angle, 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 weld that together, and then build a chute, an air chute, and close this so it's going to be a box that can bolt to here and bolt to the front end of that thing. I got to build 2 of them. So every part that you see me do for this one, I'm actually doing 2. And away we go. Okay. That moment when you realize you're about that much too short to be able to get the girl done. Sometimes I often wonder if that inch is actually that important, but in this particular circumstance, yes. Oh man. I don't want to go back over to the store. Damn it. My phone. So, I don't care if this takes me all flipping day and 15 trips at this point. I'm determined this is the way I'm going to build it. So, I got myself a decent little box going on here. And, got this set up so we'll have ourselves our nice 2-inch opening. And got it so that this piece can sit inside of here perfectly, by the way. Sit inside of there perfectly. And I mean perfectly. So I can weld all the, get it in frame perfectly so I can weld all this up. And it's getting retarded. It's sure gonna be cool when it's done. That's all I'm gonna say about that. I have a 1-to-1 opening. It'd be way overbuilt and easily able to support this thing flopping around off the backside of it. So, well, okay. Now I got to run over to the plaque shop. I got to go pick up some stuff for the brake. Whew. Man. Well, the easy part is now to come, because all I got to do is copy all the angles on this stuff, and yeah, shall return. Was this simple process so friggin' hard on the first one? I had to fight like hell to keep this one square. This one, falling right together. I gotta go clean my titty though. I just stuck it in a puddle. Oops. Everything has taken longer today than I possibly thought it ever would, but it's been fun, I'll say that much. I got to talk on the radio quite a bit today. It was kind of cool. Long time since we had Mother Nature like that. All right. Go cut this out. I'll be right back. Okay. So after a full day of dicking around with gearboxes, and that's primarily because of my own piss-ass planning, can't shoot a lot of segments of today. Just got to sit here and get back on track. I literally plan to get twice as far as I did yesterday. So right now we're going to mount up our air boxes, which are finished. Way mega overkill. Taking into account we're basically making, this is made of thick aluminum, this is made of like little pot metal. I know that we were talking about doing this as like some kind of instructional video, but I'm starting to get close to the end of my timeline, and I got a lot I got to get done on this thing. So today's goal is to get the airbox mounted, get the high voltage pass-through mounted, get the holes punched out for my filament, which are down here, get our coax connectors, and then our control plug on the back, all that mounted. Get the basic assemblage of the deck done. So it means I want to punch a hole for the tube, and I want to figure out where I'm going to put my tuners and shit. I got to get that done today. But first things first is I got to get the airbox holes cut out, which I am going to do a Manuel style. the jigsaw, and then we're going to get our high voltage lead punched out and ready to go, and then we're going to get our filaments punched out and ready to go, and then we're going to do our coax connectors and get them ready to go on both. So I will come back and shoot maybe another segment here in a little bit, but I need to fly like the wind today, especially since I took so much time yesterday, all whole whopping hour and 45 minutes to talk on my radio. So whew, gotta go. I'll be back. So, come back to this in a second. What we're doing is we're mounting our high voltage pass-throughs. This is a newer product to you guys, most of you guys I'm sure. These are made by Thermomall. This is a 10 kVA rated for 10,000 volt continuous pass-through. Okay, up to 25 amps. This is a capacitor suspended in between these two plates. Okay, and the way we're going to use it, instead of using our Molex connector, which everybody likes to use on 3000s, which are shit, the Molex connectors work good up to about 4,000 volts maybe, and then you got to take the connector itself and suspend it on another plate, or have a secondary form of insulation. Otherwise you're going to have high voltage running all over the place on you because the Molex connectors leak. Not a fan. So these ended up coming to me through another deal. A friend of mine purchased some stuff at a Hamfest, Big Rig Radio specifically, and he bought this huge thing. It had what looked like a 3000, and it turned out to be like a 2500 A2 or some shit. But these were all over the base because they were feeding everything to it with these. Okay. Well, I pulled these off and went and pulled the data sheets on these things. These things are bad to the bone pass-throughs, man. They are commercially made. They're everywhere. The part number is MS-10, 500 microfarad at 10 kVA. Okay. This is what we're going to use. These are a direct pass-through, and then there's a capacitor couplings that goes from this pin to the body. We're going to use this to pass our high voltage into the cabinet. The way they were using them is they had these attached to the filament chokes, okay, on the bottom, the low end side of the tube. And then on the top side of the tube, they had these feeding the high voltage, exact same value. I was like, oh, new technology. And then I thought about it and went, no, old technology. And let me explain to you why. The first time I was over at Prime's house, I'm not going to specifically describe how his pass-through system works for his air-cooled box, but it's got this really looks like a double-headed butt plug, almost, capacitor that goes through the cabinet in the back. It's really tricked. They're just incredibly expensive and almost impossible to find at this point. So I went, oh, old new technology. I've seen this before. I know how this works, and I understand what it is. So this is what we're going to use. Most guys are going to use the Molex connector that was made famous by Henry. They're in like every Henry cabinet ever. 2KDs, all the floor models, all their RF generators. That's where the guys get them from. So if you go to do a pass-through like this, and you're using a Molex connector, because there was a guy that just recently attempted to build a 3000. His first name is Mr. B, we'll call him. One of the major concerns some of us had, like any and all of us that know anything about making any kind of high voltage RF deck, he had the Molex connector attached directly to the cabinet, and then he had stainless or tin screws holding the Molex connector in. Use nylon connectors on the Molex connector, 1, and 2, you mount that to a piece of high temp fiberglass or fiberglass reinforced, like this. Thank God, one of us that's kind of a little bit more knowledgeable, well, actually a lot more incredibly more knowledgeable than Mr. B, got involved in that project and took it over, went down and picked up all the parts, and actually completed it for the guy that ordered it, and made it so it ran safely and properly, and thank God no one died. But all it takes is a little mistake like that, because you're cheap or you don't know or you're afraid to ask or you don't have a mentor or whatnot, and you're going to end up killing somebody with this. I don't like building these for people. I don't like building tube boxes for people at all. I normally will take and defer it off. These are two really good friends of mine that I trust, and I know that they're going to keep their fingers out of here. They're not going to be inside a cabinet. They're going to just turn it on and run it, and if they have a problem, they are technically close enough that I can drive all the way to them and have it fixed, or I can fix it for them. So remember, not only will this kill you, it's going to hurt the entire time while dying. Factual statement. Very truthful. This is, with these, very truthful. We stand at pearly gates going, oh, I was dumb. And there's been a lot of guys that have been killed from it. A lot of guys have had jewelry on. There's one dude that was doing something on his RF deck, and he had a big, like 1990s pimp gold chain around his neck, and that touched, grabbed, and the electricity flew in through his neck and came out through his hands. And that's kind of in the position his wife found him about 20 minutes later. Just seized up, standing there with the box still cooking him, because there was no safety interlocks on the box. There was no fuse, there was no glitches, there was nothing. Nothing, no cutouts, no nothing. Yeah, okay. On to another topic. As I was manufacturing the plates for the filament, where these go is these attach here. That's how they're going to look on the other side. They attach on the inside. And we use very substantial 1/4 inch thick, heavy duty non-flex. This doesn't have to be high temp because there's not going to be a lot of temperature here. Fiberboard is our insulator. We could use Teflon, a little bit soft. You could use nylon here, still even more soft. Nylon, if you present that with any kind of heat, even 120 or 130 degrees, is going to melt, and then you're going to lose your pressure on your connectors. Where this stuff, you can really ratchet down on it and it's not going nowhere. I was sitting there thinking, and this is no lie, what I've done in the last few hours here while working, I remember took me 3 days one time. The first time I did this for myself. Oh, and that's another golden rule. Don't overbuild anything for anybody else unless you built it yourself. Don't think that you can watch one of these videos and that you figured out all the little tricks because you watched me do this on video. There's a lot of stuff I'm leaving out. You can do this on your own. For sale. If you're going to build something, build it for yourself. Work all the kinks out of it on your box. Keep that box forever for notes. Take a lot of notes as you're going. Believe me when I tell you this. Take a lot of notes while you're going. I got books on everything I've ever built. I got little notepads. I write down every new thing I teach myself because there's always something new. Always something new you're teaching yourself. Write it down. We're human creatures, for God's sake. We forget everything for 10 minutes. I go to sleep, I forget everything. I'm old. I remember making this plate for the first time on my own box, and I didn't have any damn tools. And what took me about 20 minutes today, 15 minutes at the most, I remember it took me like 5 hours because I had to cut the plate out by hand with a hacksaw. I didn't even have a vise or anything. Remember, I like screwed some shit to the bench and had some washers, and I'm like, I was determined. God, I have power tools, and I've been so graced that I got so much work, and I just keep reinvesting it back into the business and keep moving forward and doing more. And like the hydraulic punch that punches these holes out. Imagine how long that takes with a hole saw, and then you're never going to get a burr-free finish. Never. The day I went and I purchased that punch, and then I bought all the dies that I thought I would ever need, I was so excited. I mean, that was expensive, don't get me wrong, but when it's something that you're going to use probably 3 or 4 times a month, worth it. So if you're watching this and you're thinking about doing what I do over here, so I tell everybody that calls me for advice on how to get started in doing what we do here, I tell them the first 3 or 4 years of your business, you don't get to keep any of the money. You've got to work another job. You've got to have another source of income. Really, here I am 7 years in, and I still really don't even get to keep the money. It goes back into the business. Or I take a large chunk of it and pay for, the brake and stuff that we're going to go do. Or I donate it off to other people for their brakes. The first 3 or 4 years, you will invest about 1,000,000% of what you make back into the business just to stay afloat. That's just the way it is. It's a complete write-off, loss. But to be able to take this thing and cut this thing with a saw, an actual real circular saw, and then put it on a real decent sander and be able to bevel the slip. I remember standing here with a file, having to bevel this edge of the plate. And the reason we have to bevel the edge of the plate is this is the floor of the deck. And we're going to mount this just like so. And you see how this leading edge comes right up against this plate? Well, if we have a square edge, we don't have any edge support. Or if we bevel this, now we've got overlap. This plate is supporting the floor. Starting to see the logic? I want to be able to slide this plate up so it's closer to center. And for us to do that, we have to cut this edge down just a little bit. I remember standing there with a file for hours and hours filing this by hand. And to be able to just whip on my power, my belt sander. done, oh, priceless. Priceless. So I just had that moment where I realized I completely screwed up. The plan originally was I was going to stick the airbox somewhere in this area, and for some reason my brain, when I went to sketch this out over here, slid it up so it'd be even with the corner. And it's all ready. I'm ready to mount it down, ready to go. Here's a problem. So, as I trim this back a bunch and slide this over just a hair and have a couple extra screw holes and give myself about an inch worth of clearance. That's an option. It's not an acceptable or safe option. And what I tell guys all the time is if you screw up, own it. Don't even pussyfoot around it. Just simply say, I screwed up. I screwed up. Okay, so the other option is I extend this box out. I extend it out 1.5 inches. And 1.5 inches will get me about 1.5 inches worth of clearance off the high voltage connector. The other option is I knock this out, take this high voltage connector out, and I move it over. And I put it underneath the box. And then build a backer plate to fill this space. Yeah. Do something, might as well do it right. Oh, God, I hate aluminum dust. I couldn't half-ass it. My wife just came home and I was joking with her. I said, man, you know, I could have made this whole box in about maybe 30 minutes out of sheet metal, right? I extended the box back by about 2 inches, and yeah, now there's no more problem. Definitely not the easy solution. Definitely not the cheap solution. I spent most of my evening working on repairing and extending this box. This is actually 2 pieces of L and then custom-made sides and tabs and inserts and horse Maloney. The way I went about doing it, probably about a $450 fix after time, labor, and parts. Maybe $500. She goes, well, it wouldn't be so cool. And I said, yeah, you're absolutely right. Moving on. Gonna let this go. I'm moving on. I actually called my business partner today. I called him. I was, hey, dude, what's up? You guys got to understand, this guy here, he's been deployed to Iraq, Afghanistan a couple times, like 15 years in Afghanistan and like 3 years or 4 years in Iraq. So he has a tendency to be a little bit, I don't know, blunt. The best way to put it. And he goes, man, what's up? I said, dude, I'm getting my ass kicked. He goes, what do you mean? I said, man, I made a small mistake today. He goes, yeah, what's that? And he goes, man, I said, dude, I got cute. He goes, oh, yeah? I said, man, I'm gonna take this this blower box. I'm gonna move it up to the right corner of the cabinet instead of moving it 1.5 inches in like I'd planned and designed and laid everything out around. He goes, okay. I said, so I went to go mount up the blower and the blower was hitting a high voltage connector. He goes, okay. I said, so instead of building a plate and moving a high voltage connector over, because then it would conflict with other things like safety reasons on the back and so on. So I spent all day busting my ass building an extension to the blower box. It's all right. Because let me guess, it's about 13 times more elaborate than it needed to be. I said, yeah. He goes, And I said, then what really sucked is I went and I mounted the blower, and then I looked down in the corner, and right where the output coax is supposed to be, the blower's sitting over it. He goes, all right. I said, man, it pisses me off because it doesn't look exactly the way I had it pictured in my head. He goes, Now, he's got this term called snowflake. He loves it. He's wrapped himself in it. And, I said, dude, I'm on my way to Home Depot. I got to go get a tool, and I got to get a body plug to stick in there. He goes, that'll look gay. I said, yeah. He goes, you can't just build some damn plate to cover it up. And I said, yeah, but that's not what I want to do. He goes, well, can you weld it up? And I said, yeah, but then I have to take everything off the plate and rebrush the aluminum. And he goes, well, I tell you what, Snowflake, sometimes you just got to suck it up. I said, yeah, thanks, dude. And he goes, no, seriously. It's like that first time you did a really, 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 really big fat chick. I was like, what? He goes, yeah, you just got to embrace that you did it, get it over with, and move on. I said, dude, well, I'm here at Home Depot. Let me call you right back. He goes, no, because I'm thinking I'm going to go to bed here in a little bit. I'm feeling a little tired. How about I catch up with you later this week, princess? Basically, quit being a bitch. Get it done. We have success, finally. Success. So, ended up having to move the PL259 connector over a little bit. That's fine. I'm just going to have to change how it's hooked to the relay a little bit. We're going to make it run across one side and flip over to the other. And easy. But one bad decision to move this to the corner instead of having this set back just a little bit. Balls have ached for it all day. We're done now. So now the next step is we're going to start putting side plates on it in the floor, and we're going to start thinking about putting the front side together. Our input tune and load, our output tune and load, that part of the network, and getting all that hardware mounted down, getting some knobs put on this sucker so we can play with our titties. And first place we're going to start is after before we even get that far is I got to knock a hole in the floor pan for the tube, and I got to get the filament leads hooked up with the bypass caps to ground off the filament, and then we can start doing some playing, because the goal is by tomorrow night I want to have all my parts out of here that need to be plated, which is the tank coil, the strap that goes around the tube, the pass bar that comes off the tube to the blocker, the rod off the blocker to the load cap, and so on. All those parts need to be in the silver solution getting chooched upon by tomorrow evening. That's my goal. So, this is where we're at. Moving forward. Princess. I can't believe he called me princess. Okay, so let me explain this mounting process. This is my buddy Lee's dud tube, famous in this series of videos. This base on this tube, this inner ring, is exactly 3 inches, not to exceed. Okay, so it's 2.099 or 2.99 or something. It's right at 3. So if you use just a regular 3-inch hydraulic punch or a 3-inch hole saw, that's in there tight. There's no side-to-side play. It's dead on. So what we do is we take 4 or 5 fairly substantial washers and some screws and a nut, and we grab a hold of this lip. and we pull down. Now, believe it or not, this lip is on the inside of this collet. So this collar sits on the outside edge. So this inside actually overlaps. And you want to put this washer directly up. Now, what I do is I drill these holes oversized, and I use a washer on the bottom, washer on the top. And what that allows us to do is when we want to go change the tube or do something with the tube, we just loosen up the nuts a little bit, and we just shift the tube around a little, boop, and it comes right out. Okay. But BBO, it seems kind of a little jinky. No, let me show you. Once again, we've got ourselves a dud tube. No good tubes will be harmed in the filming of this video. It's not coming out of there. It is not coming out of there. This plate will bend and bend and bend and bend and bend before that comes out of there. It is not coming out of there. So let me get on with it. I just wanted to stop and show you that real quick. Get this mounted down. Let me zoom in on this so you can take a quick whopper at what's going on. It's in there. Believe me when I tell you, that son of a bitch not coming out. I'm not gonna lie, the real reason I'm doing this is because I get to draw boobies. Not because I like RF power, but I like the nipples. Especially when they're right in the middle like that. I heart boobies. I do. I heart boobies. I wake up this morning and my gosh darn sprinkler controller had quit. So I just got done rewiring that, and now I get to come back over to this. Well, before I go much further, I wanted to talk about this here. There's a couple different ways you can go about doing this. You can take a ferrite donut and take your filament leads and put X amount of turns around the filament leads to get the right inductance to knock this completely out of resonance, or you can just simply do it with straight inductance. Now, there's a lot of people that argue pro and con on that. Let me show you something. The great engineers at Henry came up with just a pure induction idea long before any of us crazy sideline wannabes did. Okay, this is actually a Henry filament choke out of a Henry amplifier, 3000, and they used 12 turns of tuned induction. Okay, well, this is the same idea and the same number of turns, but I like to throw a ton of capacitance. Like these are 1,000 puff a piece, these two doorknobs at the output. And the whole idea and principle behind this is to make it so that we've got a big enough inductor to carry the AC current coming in to light the filament, but it's so far out of resonance that the RF doesn't want to go that way. It wants to go into the tube. That's the whole principle behind this. You can do a rod that's got substantial wire on it, and just turning it around a rod's going to throw it way out. And then you don't have to worry so much about the capacitors. These bypass caps back here in the corner. Bypass caps back here in the corner. I've done several 3s and several 6s like this. Now you can take your induction meter and measure the number of turns, and that induction meter will give you a number, and with a little bit of reading, something I'm not going to get into today, but a little bit of reading even in the simplest books like the ARRL handbook or some other books that I've acquired over the years, first suggested to me by my friend Chris, is William I. Orr. Way smarter than next 10 people put together as far as radio is concerned. This guy in the 40s, 50s, and 60s was the man. And he was the first person to write kind of like a precursor to the ham manual. ARRL really reaches deep into the use of his knowledge in the writing of their handbook. And he covers induction circuits as far as their resonance and how to get them in and out of resonance. And what we're wanting here is the most out of resonant thing that we can get. Okay. This circuit here will work fairly stable from about 80 meters all the way up to 6 meters for this tube, roughly. We can throw it even farther out of whack by adding a capacitor here and a capacitor here. Most people don't like to do double pump. That causes all kinds of sorts of issues, especially in this particular network. But you can increase your capacitance here. Now the way Henry got around it is they have a center conductor, and then it's lined with Teflon, and man, I don't have this technology, and I'm not interested in this. It's the same boiled down knowledge, kicked out in another way. Okay. So if we were going to add another tube to this thing, it would sit over here someplace, or it'd sit here. But then we would just take these two leads, and we bring them to a center point and feed one off to one tube and one off to the other tube. Okay. Now, let's talk about ferrite. In a lot of different applications, you'll put ferrite on any wire going in and out of any kind of RF enclosure. That's the way us DC builders think. You have to dismiss that from your brain for the most part when you're working with tubes. It's not necessary in a lot of applications, and moreover, in more applications, it'll cause you to have problems. So you can always tell when there's a DC builder that's built primarily DC, and then he decides to start building AC, there'll be a bunch of ferrite on a bunch of shit that doesn't need to be on there. And that has a tendency to cause you problems as well. This is going to be my input blocking cap. Okay. These are made by the Plastic Capacitor Company of Chicago, Illinois. This is a 0.1 microfarad capacitor. Same thing as over here in this box. Once again, exactly the same. Okay. What this does is it separates the AC voltage that's on the bottom side of the tube, keeps it on one side, and allows the RF energy to flow straight through it, and it blocks any DC currents or anything that could be on this side of the circuit from flowing back and coming back to your radio. That's all this does, is it blocks. Remember, primary capacitor's job in this particular circuit, and when we get up here, we're going to be using capacitors as blockers, because they will block DC voltage and let AC move right through them. So now, with me saying that, what I just said in a previous sentence isn't necessarily true. The AC voltage can flow through this blocker. We're using this to isolate and keep ourselves from any DC current that might be present on this side. Also, thusly, it's keeping us from having any DC current that's coming from the radio input side. This is our level of isolation to try and keep the two voltages separated. That's what that's here for. Okay, everybody got that? Good. Now, I got to run away because I got to get going here. When we get back, we're going to have our tuners, our input tuners installed. I could have used vacuum tuners, I sure could. Once again, I have to consider my customer. Okay? Vacuum tuners have a lot of turns to them. Now, I don't have a choice on the output side, and we are going to use some very expensive, like $500 a piece, vacuum tuners on the outside that are made in Japan. Not Jennings, not Russian Svetlana, actual made probably last year in Japan vacuum caps, variable vacuum caps. My customers all come from like the Henry SB220, these two guys, and they understand you're going to turn it half away, and it's going to take the tuner halfway out, and then you're going to turn it all the way, and it's going to fully intermesh it. To make it easy for them to tune their input tune, we are going to use air tuners. This is absolutely acceptable, taking into account the little amount of wattage that's present as drive for this thing. Now remember, when you're tuning to the outside world, this is what this cap does. This allows you to adjust the outside world. This is allowing you to adjust to the tube. The coil that sits in between is what determines its resonant frequency for its input. It's the same thing on the output side. You're going to have one tuner that's going to adjust to the outside world, and the other tuner which is going to match to the tube, and then you're going to have a resonant circuit that sits in between, which is your tank coil. Same thing. high capacitance on the outside world, a little bit lower capacitance on the inside world, okay, to the tube. The tube's going to be a little bit more naturally resonant than all the different possibilities of coax lengths and that kind of shit on the outside world. So 20 through 850, 20 through 250 puff, and these are like 5 to 7 kVA-ish. More than substantial for what we're working with. I'm going to get these mounted up. I'm going to put the relays in, and when I come back, we're going to have a discussion about why I'm going to use the relays that I'm using. Let me get these in, and I shall return. Okay, all joking aside, let's have ourselves a serious conversation. Now, I spent a lot of time debating in my head if I wanted to get a Gigaback, Jennings, or use open frame. This is a Jennings vacuum relay. This is what they look like. Little tiny glass bastard. It's inside of a vacuum. Those contacts are inside of a vacuum. Okay? Now we could have gone and gotten the $390 Gigaback vacuum relay and put them in here. That's what I would do for myself. Now I have a mental problem with that. Now, let me explain to you what my I wouldn't say problem. My hang up that I have with doing that for this box. I got to thinking about the very first 3000 I had, and I had open airframe relays, and I beat the snot out of that tube in that box. Everything I've built since then has got vacuum relays in it. So you go on and you learn, and in the very beginning there's a process that you have to learn, which is step on the pedal, then bring the radio and all your other drivers and stuff into operation, then kill all your radios and drivers and stuff, take them out of operation, and then you can come off the pedal for this box. Well, until you get used to that train of thought, you're running the risk of burning up the points inside your vacuum relay. Vacuum relays are much more efficient, as in because they're inside of a vacuum, there's no arc for the most part, but you can weld the leads together. I've seen it done and have had it happen and junked vacuum relays before. I got two very new guys to this whole train of thought that are going to be running these boxes. Now, it's not going to take them months and years to learn this process, but mistakes are going to happen. Like, they're not going to have their high voltage kicked on, and then they're going to step on the pedal and fire down. They're not going to see anything going on. Well, when you do that with a vacuum relay, you run the high chance of burning your contacts. Okay? Incredibly expensive. And now the contacts are welded together. And there's no way you can get in there and clean the contacts and go back to operation. That's the only downside to a vacuum relay. Now, as you go up in horsepower past a 3, this will hold to a 6, but after that, you've got to go to a vacuum relay. You have to. Now, me thinking at the bigger picture, honest to God, I've got the relays here. If it's that big of a deal, we can put the relays in here, but my guys are going to run it like this. And if they want me to come down and change their relays out, even though it's not going to help them hear any better, it's not going to help the amplifier do not even 1 more watt, I will do it. But I want them to learn how to operate this thing on open framed relays. There's a reason. They screw up their contacts because they're coming off the pedal early, or their foot slipped off, or they keyed up and the high voltage wasn't on, or whatever. I don't want to have to get on an airplane and fly down there to help them change out a vac relay. What I want them to be able to do is unplug all the accessories from the back, take the lid off, this portion. Well, take the deck out if need be, take the top and the bottom plates off, undo this single screw, and then be able to clean the contacts with a dollar bill. Take a dollar bill, you fold it in half. Take a dollar bill and you fold it in half again. That is the proper thickness, and a crisp, clean dollar bill is the proper texture. Guys, look. This is going to be your biggest indication of lost receive. It's going to be right here. These points right here. This is going to carry the most of the load. If you fire down or your foot slips off, when the foot slips off, the relay's sitting in this position. Now it's going to bust an arc, just like points in a car, up to these contacts. Okay? And it's going to cause them to burn, get carbon score. Well, all you got to do is lightly brush that carbon off and things will go back to operating the way you want them to. You take your dollar bill that's folded in half twice, and you're going to push down on the relay. This is kind of hard to do one-handed. Push down on the relay, slip the dollar bill in between the contact points, and then move in a small circular fashion, just like this. Then we do the same thing on the other side. Do not use mom's fingernail file. Do not use emery board. You don't want that. You want a very smooth, clean, polished surface. Just like that. And then on the other side, if you're daring, you will push the relay down slightly and do the same thing on the bottom set of contacts. Each side has got an oversized relay. Okay? This is an 80 amp relay. This isn't no... That's an 80 amp relay. Focus, you son of a bitch. 80 amp. We're going to use both sides of this relay for one job. To switch from the antenna going through, going down to the bottom relay, out to just carrying the horsepower of the 3000. Okay? If you manage to screw up 160 amps worth of contact on a 3000, then you've done something wrong in the operation of keying it down and unkeying it. If that happens, I want to make it easy for my customer in the beginning to be able to just simply take the lid off the cabinet with the whole thing de-energized and unplugged and the whole 9 yards, and you know, the high voltage is bled off and the high voltage is disconnected and all that kind of thing. All those safety things are done. Be able to reach in here and clean his contacts, put his lid back on the relay, put the lid back on the box, hook up all his high voltage stuff, turn his stuff back on and go back to running. It's part of the learning process. It is. Now, if we went to a pair of threes, no way and holy Jesus would that carry enough current. No way. No way. Or a pair of sixes or a 10. That's just one of the things that we'd have to change up. And let's face it, jumping from a single 3 to a 6 is not that big of a deal, but jumping from a single 3 to a pair of 3s, that's going to require the amp deck coming back here and us rebuilding this bottom plate and changing a whole bunch of stuff around. Plus changing the roof, plus on and on and on and on and on. Okay? The guys contracted me to do a single 3000. They did not contract me to do 2 3s. I did that as a courtesy to them. The power supply, the filament, make it so that they could run a 6 or a pair of 3s or a pair of 6s. The big expensive bits, the transformer, the filament, that kind of stuff. So if we want to in the future, we can expand that direction. But for right now, I have to meet the parameters to run a single 3 and make an environment to where it's going to be friendly for them to make mistakes and it's not going to cost them an arm and a leg and part of their penis. You go and screw up one of them small gigavac relays, they're $300-400 out the window, plus my time to come down and change out the relay. Or if we go with old reliable that I know my guys are going to understand, undo the 15 screws on the lid, the 15-20 screws on the bottom, take the thing out, flip it over, open it up, whatever. All we got to do is pull this plastic cover off, clean the relay. That's the reason I went with open airframe relays. Some people are going to dog me on this. There are going to be a lot of opinions about this. There's a reason that I went with this, and that is my reasoning. And like I said, I've got the relays. If we need to change them out in the future, we can. But this is the direction that we're headed. And this is where we're going to stay with, too. It's not open for decision. It's not like the guys can call me up and say, hey, man, how about you change those over to vacuum relays? Nope. This is what you're going to learn how to break your stuff on. For the obvious reasons. If they want to upgrade in the future, I'll come take care of that for them. But for right now, this is where they need to be. And there's logic behind it. These guys aren't masters yet. And it's absolutely too big of an overkill for this particular project. For right now, that'll work perfectly, and it'll give them margin for error that they can easily correct themselves, and their whole box isn't down. I'm going to leave it right there. These are staying in here no matter what, and they're going to go to get delivered because this is more than adequate. Okay. Now we got that out of the way. I got to mount up my load and tune tuners, and I got to build myself a tank coil, and I got to get my strap built for on my tube, and my blocker built, and all the other little bits in here because I am going to be in Silver Dip tonight. When I come back, my tuners will be mounted. I'll see you in a minute. Well, it's 3 a.m. and we're completely mocked up now. I actually used this one to mock everything up in. I just used one amplifier, and then I brought this one up and put all the pieces in it. Got our tank coils installed. Got them all pre-wrapped. These are soldered. All the ends are soldered on everything. And the reason we want to solder them is when we go and we submerge them and we do the silver plate, we don't want to have any moisture stuck inside the coils ever, because then it'll leak out and it'll corrode. I got to do the same thing with these end bars. I'm still not too sure if this is the way I want to go on these. The idea here is that we take a short little copper jumper and we come down to this side of the relay, and another little short copper jumper and we come down to this side of the relay. And the reason we got to make this distance from here to here shorter is to compensate on the distance from here to here. So we're going to use both sides of the relay so we can get that magical 160 amps worth of current out of the relay. Otherwise it's going to burn up one side, most of the load's going to go through one side, and we're going to have issues. So bottom side is fully populated out for the most part. I've got to run some coax and create the coil on that tomorrow. That won't take too long. And then I've got to hook up the relay and then run a piece of coax from the bottom down here up to the top relay, so we can talk through the box, do our pass-through tune. Then we're going to fully disassemble all of this, all of these pieces, which there are many. And then we're going to disassemble everything on the bottom, and then we're going to dunk it, and we are going to silver plate it. The only thing I have left to build here is the strap that comes off of the blocker and goes around the anode of the tube, which will take about 5 whole minutes. I can't stand any longer, otherwise I'd stay out here and I'd get this strap built, and then I would get my little feeders done. But man, I've been standing out here now since frickin' 9:30 this morning. Back's starting to hurt pretty good. So tomorrow the goal is to get all this stuff, get these little short jumpers done, get the relay and the coax all routed from the input relay over to the tuners, over to the tube, through the blocker, and then get all this disassembled, all these pieces, and get everything plated and reassembled back in here. And while we're plating these things, that's when I'm going to build my tank choke, and then we're going to have another glitch choke that's going to sit over here in the corner. And the whole idea behind a glitch choke is to catch any AC if the blockers for any reason fail. Now these are two 40 kVA at 20 megahertz, 40 kVA at 20 megahertz doorknobs. Okay. They're 2,000 puff a piece, so 1,000 puff, which will put us right perfect for our X factor on our dip, or not our X factor, our Q factor on our dip. And yeah, we're like right where I want to be. And the other reason is it's 3 a.m. in the morning and it's pitch ass black outside. So if I try to silver plate this stuff, it's not going to show up too well on camera. I'm going to be out there with a flashlight shining it in a bucket, and you guys are going to be like, well, I don't understand. That's not the kind of amplifier pornography that I like to provide to you guys. So now is a good time to stop. I'm tired. My brain's tired. My hands are tired. My back hurts. I'm old and feeble. And pretty soon I'm going to be arguing and complaining about how it's dragging in the dirt like an old dog. So, yep, that note, I'm out of here. I'll see you guys tomorrow. Bump, bump. Okay, so now we're working on the pass-through tune on the Demon, getting all the relays set up. So, looking at that top left number, it's a 1.05 all the way down, geez, well below 160. Sorry. 24 megahertz, 1.035, 30, 32, and then it finally starts to come up above 1.05, 35 megahertz. Pass-through tune on the Demon. Demon, emulated input tune. So we're simulating the tube in operation without having anything plugged into it. I'm not going to talk about the specifics of that, but a 1.02 titties. Alright, let's go look at the output side. Alright, so once we are on the Demon, now we're looking back into the amp deck, looking at the output network. And right now we're shooting for our lowest reflect that we can get. We're looking at M1, which is on the top left. That is 27.3844. I can't do 385. It doesn't let me do that, and the network analyzer doesn't. Okay. So now we're going to roll this over for the lower end of the band. And I can sit here and twiddly-dib with it until the cows come home, but the guy that owns this thing wanted very, very, very fine adjustment, because I don't want to have to turn it and turn it and turn it and turn it and turn it. Well, that's about as resonant as you're ever going to get. Let me show you what I'm doing here for adjustment on the front. Okay, so right now we're set up just where we left off for like 27.025. Now watch what I'm doing with my hand here. Look at how small I'm having to move this. Okay, now I'm going to let go of this knob. I'm going to turn this knob. I'm going to come back over here and just slightly adjust this one. So now we're perfectly in resonance again for like channel 38. I literally moved from here to here and from here down to here. Very fine, very, very fine adjustment. Now the only difference between this and any amateur box on the face of the earth is the length of this output induction coil and the length of the coil in between these two tuners on the bottom, your input tuner coil. Otherwise, this is the exact same device. Exact same as the 3500Z, exact same as 8877, 3cx3000. This whole portion, the input and output portion, the only thing that's different is bigger parts. Okay, I want to show you something here. We're going to go out to 50 kcs wide. We'll go to 10 megahertz. Okay, so right now the center delineator is at 27 megahertz. This thing's going to jump all over the place because my hands are near the output tank coil. So we'll say here this is, set this up for the entire chicken band basically, just for fun. What I'm showing you is we can basically get a flat response anywhere you'd ever want to talk. And it's all within this tiny little window. Now let's go ahead and we'll do span again. We're going to move this out to 100 megahertz. So now we're looking from 0 all the way up to 50. This thing will not pass any RF outside of this dip well. Okay? So let's readjust our meters again. From there to there. You're starting to notice how finite this band is. That's the entire amount of frequency that we're allowed to use. But we can make this go work anywhere just by changing the length of the coil. This dip is really important to achieve this tight of a dip. So if there's any other harmonics that the box is trying to produce, or the radio's putting into it, the amplifier won't amplify it. This is the output network that we're looking at. We are literally hooked up to the output coax connector of the box right now, and we're looking back at the tune and the load tuners and the tank coil and the blocking capacitor and the glitch chokes and the bypass cap and the whole circuit. We're looking at the whole circuit. This is the only things that'll ever be able to resonate. And these little tiny ticks that are up here in the corner, so they're affected just by my hand, but look at the center delineator. It stays rock solid. So anything other than maybe 1 megahertz, it's not coming out of this box. This thing is a natural trap network. That's the whole point behind tubes. They're so naturally clean. Okay, so yay! I get to do my most favorite part and the most dangerous part. What we're going to do next, guys, is we're going to silver plate. Since this is all now tested, and both boxes are built exactly the same, there's a couple things I want to go change on the other one, on the Exorcist, to match up with this one. As I made other adjustments, like the pass-through tune, I know that I got to add 60 puff to the relay. Other than that, everything stays basically the way it was, just from build date. So now I'm going to do one box at a time. Okay, so first I'm going to completely disassemble this thing. So everything I spent all these days putting together, I'm going to completely bust it down. I'm going to double check it, and then we're going to clean it. And that's where we're going to come back, is me cleaning everything to get ready to go dip it. We shall return. Coming down to the tail end of this one too. Okay guys, we're on the Exorcist, and I wanted to show you, this is the input tune, and then I wanted to show you this. So 1.016.
Yes, master. Right.
So I hope you all understand how this chart works. This is the most resonant point that it's going to be. This is your lowest SWR. And then that's going up. So this is 27.025, and then here's like 38. This other marker is 38, the green marker. So I want to show you how little amount of movement it takes to take the thing from resonance on the bowl you can get it perfectly flat just by literally moving these just a couple needles width. So large inputs are not necessarily what you're looking for here. Let's change our span. We're going to go out to 10. That's a beautiful dip. Absolute beautiful grid dip. Beautiful, right? Change span again. We're going to go to 100 megahertz wide, so 50 some megahertz wide. So input, our input dip, I'm not kidding you, is maybe only maybe 250 megahertz wide max before it falls completely out of resonance. I mean, we're talking the upper end of this is 75 to 1. Once again, very cancellation of harmonics. Okay, so Exorcist, and this is what the actual tube that we're going to use. Actual resonant. This is the tube that's, I just installed the tube. So Let me go ahead and get the rest of this put together, and I will show you output emulated load. Okay. This is with us emulating tube operation once again with the actual brand new iMac tube that's in this thing. And I'll call 1.01, 1.022 resonant. That's the red marker. Let me zoom in here for you guys. Make it a little bit easier for you guys that are on cell phones. Okay, so the red marker's at 27.026. And with a quarter turn adjustment and another quarter turn adjustment, now we're perfectly in resonance once again. With 27.380, so the upper end. Like I said, we can make this box work anywhere anybody wants. All you got to do is just change the tank coils and the input tune coil. Okay, let's get on with this thing. Okay, the Exorcist, and here's our pass-through tune, which is a 1.07. It's pretty stinking good. That's our ability to talk through it and hear through the amp. So this is my opportunity to go over every single piece. Silver plating is expensive. Time is expensive. Everything costs at this point. So the very first step we do with plating is we got to make sure all of our oils and residues and fluxes and fingerprints and that kind of stuff are removed. Hold on, I gotta kill my vape machine. Are removed. So with clean paper towels and fresh clean gloves, we go over every little hunk of copper and then set it aside. Now what we're using is acetone. Okay, same ketone chain as like methyl ethyl ketone, just not quite as aggressive. This is what allows us to get rid of all our flux. Remember, we sweated some of these parts together to make sure they're sealed. It's really important. Like, we sweated the end of this thing together to make sure that there was no way the water, because they dilute the solution. They dilute the silver plating solution in distilled water. My silver plating solution, I had to sit down and think about it the other day. It's been so long since I even thought about this. I have it, oh shoot, blew through my glove. I have it mixed with silver iodine to separate, and when we go and do the plating process, it pulls the iodine out of, or the silver out of the iodine. It's like silver merchloride or something. Works out to be silver iodine. So, now the silver doesn't care. It'll plate to the lead just as well as it will the copper. This is honestly my most favorite part. So you want to get all this really clean and you want to keep it fingerprint free. Any kind of oxidization, any kind of corrosion, anything, we've got to remove that now. Polish it, whatever, because it's going to be there forever. And this is called prep work. So like the edge of this piece of copper had itself a little bit of Sharpie marker on it. It's got flux and everything all over it. If you have oil on here or you got flux, from you soldering parts on here, this little spacer that's on here, I sweated this spacer on the back, it won't plate. It'll just chip off and you get an ugly plate. It'll look bad. Now I'm going to only show you this on one box because it'll take too much time, and I am on a insane tight timeline with these two builds. I've really got to start hustling along. As soon as I get these in the dip, I got to come back and get the other box prepped up, ready to go. So this is phase one. Okay, this is just to get the general oils off and the flux off. These aren't technically, I wouldn't consider these even clean yet. These are just prepped. I cannot stress to you how important this is, that you do a thorough cleaning job. This is where the rubber meets the road. It's also your hardest thing to get a consistent plate on, from what I've figured out. Because a lot of people like to touch their tank coils and stuff, which is fine. Touch away. The trick to getting a good plate on this is having it stupid clean and no oxidation on anything. This is my last opportunity to go along and knock all burrs off of things and sharp edges and stuff that'll screw you up. My gloves are coming apart again. Remember, surface area is your #1 friend in building tank coils, tuning circuits, that kind of thing. Contact surface area, contact surface area, contact surface area. Okay, let's go get the 5-gallon bug jug of death here. Okay, so now that we got all the oils off with a little acetone wipe, okay, our next step is to shine these up like a pretty penny. I'm going to take some steel wool to it, really fine steel wool, and we're going to use this again once we're done. Just give it a nice little rough little scuff, okay? And you always got to pay real close attention to your edges of your metal. And this will help remove the last layer, little bit of layer of any kind of oxidization to the copper. And any last little bit of patina or flux or dirt. Because you want to have really clean metal. Really important, you want to have clean metal. So, like, see, there's a little bit of discolorization there. If I don't get that off, it'll plate over it. But then when I come back and I go to rub on it to knock the oxidation that takes place in the plating process off, it'll just knock the plate off. This is really important. Like crazy, crazy, crazy. Crazy, wicked, like meth head Betty crazy important. So now that it's quiet outside and there's no thunderstorms going on, my neighbor's not trying to mow their lawns or nothing. As soon as we get this done, I shoot this with some Colleen, which is a pre-prep product, and then we're going to go dip this in distilled water, the diluted silver oxide, and then the silver nitrate that's diluted. That stuff's so horrible that they say if it somehow magically gets ingested that you're supposed to induce vomiting as much as possible for up to 5 minutes. It says it on the bottle. or most stuff, they're like, contact a physician immediately. No, this stuff's so caustic, they just want you to get it out of your system. So we use all kinds of personal protection gear, safety squints, cod piece, you know, made of tin foil around my nuts, respirator, the whole 9 yards. It's no joke. So, I mean, it doesn't look like nothing. It's just a bucket and a power supply, but the gas that comes off of this is horribly bad for you. The sacrifices we make for radio, right, guys? Okay, so now that we have that all completed, we're going to take some 9-gauge wire, otherwise 16-gauge wire here, and we're going to create our anode. So our cathode is going to be, we're going to create our cathode. Our anode is solid copper bars that I have silver welded back together. So I went and got a whole bunch of, you know, true couple ounce silver ingots and soldered them together with silver, not with lead. I don't want to misspeak as I say this now. That would be horribly bad. As I'm looking down, I realized I didn't even... So, silver plating, let's talk about this, the pros and the cons. Pros, it keeps the copper from turning green. Con, it's expensive, time-consuming, caustic, and very hazardous. Does not really help you that much with output power. It will not allow you to make one more single watt, contrary to popular belief. Until you get up past 900 megahertz, it will not help you whatsoever. But I prefer silver plating, it looks prettier. Period. Really, it just looks prettier. Measurably, no difference. None whatsoever in output power potential. So we're working in a spherical container. Okay, we're not working in a square bath where we're going to have multiple screens of positive current. We're going to have a single anode. Or if you did, like if I did this commercially, we would have a screen that would go in a square tank. You'd have a screen and a screen that were made of silver, and then you'd want to put whatever you're going to electroplate in between the screens. Okay, that way as the current flows from positive to negative, yeah, from the anode to the cathode. I'm so tired, you guys. I've literally put in, I'm sleeping like 4 or 5 hours a night. I just got to get these done. So my brain is like mush. But as the current flows between those screens out to the component, okay, what will happen is, because we're in a spherical container with a single anode in it. If the anode's sitting here and this part's sitting here, this side of the part, because it's the path of least resistance, will receive more silver plate. So what we have to do is move the anode multiple times in timed increments around the component to make sure that we get a thorough coating. Very important, very important. So like I said, we had to create our own cathode. This is literally going to stick outside the bucket. And we're going to feed our jubies, our little juice, juby jupes, in from here. The current's going to, and pull silver electroplatedly onto the material. Because now we're clean, we're polished, and just before I dunk it, I'll spritz it with this stuff called clean. Here we go. So this is a fairly low amperage, low voltage process. Now this is just going to sit there and cook. As you can see, it's starting to steam up and bubble through the water. And the copper has already started to turn silver. So this is where it sits for the next 15-20 minutes. And then we will take our anode, move it to the other side of the cathode. So as you can see right here, we're getting plating taking place on this process, and nothing is taking place over here. It's bubbling all on this side. See, electrons, as they move through the water, they're taking the path of least resistance. Looks like something out of a weird horror movie. You see the silver literally coming off the bar, moving its way over to what we're plating. It's just looks like a weird 3D ghost image coming off of there. Of course, we got a fan blowing across it because the fumes that are coming up out of this bucket are arsenic and a whole bunch of different sulfides, which we don't want to inhale. Alright, I'm going to leave this to do its thing. I'm a mess. This shop's a mess. This room I'm in's a mess. Everything's a mess. Because I've just been flat out going on this project non-stop. I'm officially, as soon as I get these parts back inside this deck, they're both 99% completed. So I've got the small things to do left, like mount the amp board, hook up the filament, hook up the bias, hook up my metering circuit, and hook up on-off switches and build the front faceplate for it and put the meters on. Which is no small feat all on its own, but we're there. Now I've learned that we don't go strip our wires off right away. We give it a few minutes. So when we can come back and we'll knock the silver oxidation off with this very thin, fine steel wool. It's like this. Shiny, pretty, clean, silver plated. Not very thick silver plating, but it is silver plated. We'd have to spend a ton more time in there to get stupid thick silver plating on it, but that's not what we're after. As long as we've got the coating on the outside and there's no thin spots, we're golden. Look at that. I love this part of the build because it means I'm getting close to the very end of things. And I can finally let myself mentally wind down a little bit. The beginning of this project, you feel like you're at the very bottom of Mount Everest. Okay, and with the end of the silver plate, I feel like I'm at the top of Mount Everest, and now it's time to start making the trek down the hill. Now I can still fail, like coming down Mount Everest, right? But the odds are starting to get smaller, and with each step it gets less and less and less. Beautiful, right? Here we'll do the part that everybody stares at the most. The effing tank coil. I might have problems with these tubes. I don't know. I don't think so. They're new. But you never know. There's still all kinds of other issues I could have. But I'm pretty sure they're all going to be minor at this point. Small little problems that we can quickly work ourselves through. I know this, I'm so mentally fried between all the different things I've had going on this week, plus trying to bust out on this thing all week. And the week before and the week before is I gotta take this evening and just sleep and rest and not be out here standing up. So when I built these workbenches, I built them so that they were my sized. Anybody that comes over here, they hate it because they can't even get a screwdriver off the wall. So to sit at these benches and do this is impossible. And that's to try and help me keep from turning into the giant orca whale. You know, God knows I'm fat enough, I've already got like a blowhole on the back of my neck, but I don't know, I meet these radio guys and they're huge. Huge. Huge people. I'm a big kid, but I don't want to get stupid big. See how that just cleans right up? So, before and after. Now to do the final assemblage. I got to pull the mock-up dud tube out and put all these parts in it, and then put the actual tube that we're going to use to run the box with in there. And the only thing left I have to do to the amp deck is, like I said, build brackets to mount it, which will only take an hour or so. And then I got to punch a hole in the bottom of the deck so I can move some air across the filament leads in the bottom side of the tube, which I'm going to do with a 120mm fan recessed into the amp deck. The amp deck's going to sit like this high off the shelf, and it's going to suck cool air in and blow cool air across the filament leads. That way we have a good 12 inches of separation between the inlet fan for the RF deck and the exhaust fan, or the exhaust port on the deck. So we won't get any of that, quote, recirculation of air, which is really important. Anyhow, I leave these wires on until I get them buffed out, because if I find a thin spot, or if I got a piece that's a little thin in the coat, all I got to do is hook it back up and drop it back in there for a little bit and thicken the coat up a little bit wherever I want. But I don't see this being a problem. I think we're going to be fine. The first one I did this on was my 6. I wanted to learn how to silver plate. I got really frustrated. I called around and called around and called around, and there's no place locally that does silver coating because it's so caustic and so non-EPA friendly, right? And finally I called this one shop, and the guy goes, man, you can send it out to Seattle and have it back in 6 to 8 weeks. He goes, if you're just talking about doing some small parts, you should probably think about doing them yourself. I was like, well, let's look into what that took. And after seeing how simple the process was, you know, because everybody becomes an expert on watching a YouTube video. Made you look. And doing a whole bunch of reading, I was like, wow, this is stupid simple, and I think I could do this myself. So I bought the chemicals and started playing with it, and then I invested the money in the silver bars. That was not cheap, by the way. But that works way better than the stainless steel anode. Way better. Way better. And then understanding which chemical to buy. And then the proper prep. The prep is 99%, 99999% of everything. I'm waiting for the dude that wants to call me up and have everything inside of his deck gold plated. Hasn't happened yet, but I'm sure that day will come eventually. Alright, last piece, and then I can start cleaning. I'm going to clean this room top to bottom. I can't stand it anymore. It's a lot of energy and effort. Such a small little thing. Seems to be some serious confusion going on Facebook about how these tubes are going to get cooled. So I thought I'd break it out for everybody really simply. The air comes in from over here, from our 400 or 500 CFM blower. Because the air box is channeled the way it is, the air hits this wall first and it hits it directly here. On the opposite side of the tube. Hits this wall, which is going to cause it to bounce this direction. So it's going to blow across our blockers, giving us more key down time and more adequate cooling. It's going to hit this wall and turbulent. It'll start tumbling at this point. And it's going to hit and come across our tank coil, giving us even more cooling. The air is going to tumble through this space. There's going to be a low pressure that's all the way around the base of the 3000, because the chimney, the Teflon chimney, will sit like this, and this will sit like so. So the air is going to spin around the inside of the cabinet, touching the whole body of the tube. And the only way for the air to get out is up through the tube. It's going to shoot around, hit our blockers, hit our tank coil, hit our relay, and tumble. But we're going to be able to cool our blockers, our tank coil, our tuners, our relay. And then, after we've got done sucking up, preloading any little bit of heat that we can anywhere inside the box, then it's going to wrap around and go straight out the top. Now, you guys are asking yourselves, what about the filament? It's a good question. And I will explain that tomorrow when I come out and I complete these. And I'll have them mounted tomorrow. And I'm pretty sure I'll be making power come Sunday. I think I'm on track and on time. The filament doesn't take as much cooling as you think, but it does require a great deal of air. And trust me, I have a plan. I can't stand anymore, you guys. I have spent literally at least 14 hours a day out here for the last 7 days straight. 14 to 18 hours a day on these. This is the final assembly. The only thing I might change in here, depending on what happens, might be the tubes, but I doubt it. These are tested, so we'll see. Gentlemen, the end of part 3. Part 4 will be up in the middle of next week. Good night.